So now let's start with chapter 3, that is user defined methods. So now let's start with chapter 3, that is user defined methods. What are methods? This is the first question that will come to your mind when studying user defined methods. A program consists of instructions given to a computer. These instructions initiate some action and hence some executable instructions, sometimes called executable instructions. These executable instructions are specified through methods or functions. A method is a sequence of some declaration and executable statements. The executable statements and declaration. What are executable statements? For example, system.out.println, if, for loop, etc. These are executable statements that we write to order the device to do something. Okay. What are declaration? Declaration are just creating of memory space, or allocating of memory space, declaring some variables, declaring some constants. So method is a place where these both things are done. Okay, there comes class, then there may be many methods. So there are method, and then inside that method there are declaration and executable statements. Okay, so what are methods? Methods are basically part of programs where declaration and executable statements are method is a sequence of some declaration and executable statements. Simple. Why are methods required? Reasons why we use method/functions: to cope with complex problems, to hide low level details, to reuse portions of code. For example, you have to take out average of a number many a times, so you create a method of average. Okay, there is a number of which you have to take out a square of, so you create a function square. Here you write the code that has to be done again and again, so you don't have to write square again and again when you are doing. For example, print the square of first 10 numbers. So there are some portions of the code that can be used again. We can use a loop, but think of complex programs, think of large programs where it becomes very difficult to cope with the loop, all the parts written in it. So it divides it into forms, it becomes easier to read. So hence, to cope with complex problems, to reuse portions of code, you can, for example, if we create a method for squaring a number, so we can use that method again and again, and to hide low level details. Okay, so how to define methods? Methods, first we have to write access specifiers that I have explained: public, private, protected and default, or nothing. We'll discuss them in brief in later chapter. Modifiers are basically, as the name suggests, keywords that modify a method. There may be different modifiers. And there is return type. Okay, the method needs to have a return type, a data type that it returns, and then a parameter list, and then comes the method body. So access specifiers: public, private, protected. Modifiers: final, native, synchronized, transient, volatile. So these are some modifiers that we use to modify the function or the method. Return type: any valid Java data type, or if no return, void. So if there is a return type, any valid Java data type will work as a return type. But if there is no return, or you are returning no value where you are calling the method, then we use void. Void is a keyword that signifies that there is no return type of the method or function. Then comes method name. It has valid Java identifier. Method name is a valid Java identifier. We have discussed what identifiers are, so it's easy. Parameter list. Parameter list is the parameters, is the list of parameters you require to do the function. Okay, for example, as we were discussing square, so you need to take a number. Okay, so int a, so you need to input a value of a to square it. So how we'll write a function to square a number? Okay, first we'll write access specifier public, modifier static. Modifier is not required as such, you can skip modifier. Public static, we are returning an int value. Okay, returning int value, int sq, int x. Okay, now return x into x. So here the value of square of x is returned, and therefore the program will end here. How to access that method? We have created that square method. Now how to access it? So for example, we have there was our int. Okay, here it is written float area float xy. So we have to write int. Now this is an example, float area float x comma y. This is the definition of a method. Now float z equal to area length comma width. Okay, now for example, if we have to store in int z equal to object dot square sq the value, for example 5. So z's value will be 25. Why? Because in the return, this is where the value is returned, where we call. So we return x comma x into x. So z will be in z, the object will return 5 into 5, that is 25. Okay, there now parameters, there are two types of parameters, formal parameters and actual parameters. Okay, now here square was a method, square had x. X is the formal parameter, but y is the but 5 is the actual parameter. X is just formally there, that something needs to be there, but 5 is the actual parameter because we are using 5 to run that method. Now call by value and call by reference. This is another interesting topic. In call by value, new copies are created, therefore no changes are made to the original. In call by reference, new copies are not created, therefore the change is made in original storage space. This is basically theoretical questions come from this. The question that may come is differentiate between call by value and call by reference. You just have to write these 2 points. Okay, now what is call by value? For example, int a. For example, int a, and we are using int call by value. So a new copy will be created. Int for example, int x will be given the value of a, and then the changes will be made to x. Here a remains, here a no change, all the changes done are done to x. But in call by reference, int a is directly used, so a plus plus, here a changes done. So basically in call by value, there are new copies created and no changes made to the original copy. But in call by reference, new copies are not created, the changes made are into the original storage space. Now return. I'm just, from the start of the chapter, I am repeating return. What is return? Return is a keyword. There is an error in this. You have to spot it. 3, 2, 1. Keywords never start with capital letters. Keyword never have capital letters. It will be r small r. So return is the keyword. Return has two uses. One, to terminate a method, and two, to return a value of the calling code. First is it terminates the method. If you write return, and while executing the method, when the compiler reaches return, the method is then terminated. The method stops executing, and also returns a value to the calling code. Where you call something, when you are calling the method, it returns a value there. There may be more than one return statement, but only one is executed. If the first one is executed, obviously the method will be terminated and the next return statements will not be executed. Then comes the return value may be valid Java data type, or if method does not return value, it is of void type. Now topic 3.7, pure and impure methods. Pure function does not modify objects. For example, public static boolean after time 1, time 2. Boolean result equals to if time 1 time1 dot r greater than time2 dot r, true, false, return result. Impure function, public static void forward time1 dot r plus equal to 1. Here there is no changes made to the object, we are just referring to its variables, but in this case the object's variables are referred and also changed. Now if you did not understand the functions, this is the basic this is the explanation. Time and time1 time2 are basically two objects of a class named time. Okay, we are storing time in an object named time. Time is the class and time1 is the object, time2 is the object. So time has hour, minute, second, both has, from what we know, it has both have one variable, that is r. Boolean result, so we are declaring a variable named result, that is of Boolean data type. Result equal to time1 dot this is conditional operator. What it does is, it is a short form for if statement. If you just have to return, if you just have to provide values to a variable with condition, we use conditional operator and not if else statement. Result 1, if time1 dot r, if time1 dot r is greater than time2 dot r, then if it is true, then result will become true. If it is false, then result will become false. What it does is, if the statement returned before the question mark is true, it gives the first value to the variable. If it is false, it gives the second value to the variable. Now we'll return result. If for example time1 dot r equals to 5, time2 dot r equals to 2, it will return true because 5 is greater than 2, true. So first value will be given, that is true. Now in the second one, forward time1 dot r plus equal to 1. For example, if it was 5, it will become 6. So here object is changed, here object is not changed. That is the major difference between pure and impure method. Now comes the topic 3.8, function overloading. When more than one function are declared with the same name and scope, it is called function overloading. Different functions are differentiated with number of parameters or data types of the parameters. For example, float area int x comma y, float area float x comma float y. For example, there is a area. Now you don't know if the variable will be int or float, so you create both the methods with the same name. So you don't have to write the statement again and again. You just have to call int area 5 comma 6. So it will run this method because the parameters are matching. 5 is int, 6 is int. So the parameters are matching with the first method. So the first method will be run. But if you write area 6 comma 0, 7 comma 1. So here both are floating point. Both are in decimals. So both becomes float data type. So here the second method will be run. Overloading is basically using the same name to for many functions. This is a property of OOP, polymorphism. Here we are using the same name to do different things. Now why is it needed? Okay, now why is it needed? It is needed because we are just thinking of a small programs, but we write a lot of programs. There are many functions that do the same thing but for different types of data types. So we use the same name because we don't have to again and again check. For example, if we had given area 1 and area 2, we had to check if for int what is the area, then we have to write area 1. For float what is the area 2. So we have to write area 2. But here we just have to write area. So it becomes very easy for the software developers or the coders or the programmers to do coding. This was chapter 3. This is a very small chapter, very easy chapter. This means basically the major topics with theoretical questions, where theoretical questions come from. So this is a chapter you have to learn and not understand. Understanding is important, but more learning. Thank you.